Okay, open to page 9 in your packet and try these 8 exponential properties at the top. We're going to pause the video for you to try them in your groups. Okay, so for number 1, anything to the 0 is 1. For number 2, when you have a negative exponent, it moves that term to the other side of the fraction and makes the exponent positive. So a better way to see that would be 1 over a to the first. In number 3, the 1/2 we would rewrite as a square root. And in 4, the 1/3 power is a cube root. So it would be the cube root of a. Let me make it bigger so I can write better. There we go. Let's try this again. The cube root of a. In number 5, when you multiply and the bases are the same, we add exponents. So for 5, it becomes a to the x plus t. In 6, when you divide, we subtract exponents to simplify. And in 7, when you have an exponent to an exponent, we multiply exponents. And in 8, we have a negative exponent again, so it moves to the other side of the fraction. Like if you've envisioned that's over 1, this whole term moves to the denominator, but then the exponent becomes positive. Okay, so on page 10, I think it's page 10 in your packet. Might be page 9. Oh, sorry, no, page 9. My apologies, page 9. Right now we're in what would be considered chapter 1 because of this 1.5. So when we get to chapter 5 in a little bit down the way, we will learn how to find the exact value at which a function changes concavity. So for now, we're just going to approximate. So look at the, draw the graph to the right and label your x and y values. I'll pause the video to give you 30 seconds to do that. Okay, so for increasing and decreasing, those values change at a maximum or minimum. So I would say this graph is decreasing from -infinity to 2, and again, from 4 to infinity. And then the graph is increasing from 2 to 4. Now for the, where does the graph change concavity? It looks like about here at 3, the x value of 3 is when the curve starts to change. So like if you start to draw this, this is our concave up like a cup. And right about here, so if we're drawing it up like a cup, right about here we start to draw the down, the concave down part. So I would say it's concave up from -infinity to 3, and it's concave down from 3 to infinity. Okay, we're going to pause the video here for you to write the power function definition. So a power function is one where the dependent value is proportional to the power of the independent variable. So dependent is y, independent is x. So in general, what a power function is where you have x to an exponent. So you see down here in these graphs, we have some odd exponents, x, x to the third, and x to the fifth. Those would be power functions. And then over here we have x squared, x to the fourth, and x to the sixth. So we'll pause the video here for you to sketch these graphs. My labels got cut off. This green curve is x to the fifth. The red one is x to the third. And the black line is plain x. And then over here, this widest graph is x squared. The in-between brown graph is x to the 4th, and the green one is x to the 6th, because that increases the fastest. So we'll pause the video here for you to sketch the graphs, and then we will discuss the question at the bottom. Okay, so you notice these odd powers, they all increase for the entire domain from negative infinity to infinity. And they're symmetrical with the origin, which means if you rotate 180 degrees on the origin, the graphs will look the same. Whereas the even powers, they have parts that decrease and then parts that increase, and they're symmetrical with the y-axis, which is actually called even symmetry. That's where they get the name from. So what points do all odd and all even powers pass through? Okay, so we'll pause the video here for you to answer about odd and even. Okay, so for odd, you should have said -1, 1, 0, 0, and +1, +1. So that's here, here, and here. They all intersect. And the even graphs pass through -1, +1, 0, 0, and 1, 1. Here, here, and here. Okay, so continuing on. As x goes to infinity, higher powers of x dominate the lower powers of x for all large values of x. So what that's saying is, as x goes to infinity, for large values of x, dominate means higher y values. So this first graph on the left, and we will pause it and give you a chance to draw it. I want you to notice that I'm saying the x scale goes from 0 to 5. So this is 1, 2, 3, 4, 5. But the y scale goes up to 100. So I labeled that by tens. So make a sketch. We've got this black graph down here is plain x. Then you've got x squared, x cubed, x to the 4th, x to the 5th, and x to the 6th. So just make a sketch of those 6 graphs. We'll pause the video for you to do that. Okay, so then what this top is saying, let's say we want to look here at 2, at this x value of 2. It's saying as the function has a higher exponent, so x to the 5th, that's going to have higher y values at 2 compared to x to the 4th, which is down here, compared to x to the 3rd, x squared, and x. So as x goes to infinity, the higher powers, the functions that have the higher exponents, will have higher y values than functions that have lower exponents. Now, if we look only to an x value of 1, that's reversed. It's switched. The smaller powers will dominate, meaning have a higher y. So again, it's the same graphs. The black one is x, and then we've got x squared, x to the 3rd, x to the 4th, x to the 5th, and x to the 6th. And what you'll notice, so let's say approximately here at a half. The power of the value here at x squared is higher than the power at x to the 3rd. I'm sorry, the value at x to the 3rd. So 1/2 squared is going to be greater than 1/2 cubed. That y value is greater. So we can use that for number 2. It says, which function, y1 or y2, is larger as x goes to infinity? And on your quiz, it's going to say explain. And anytime a question says explain, you must write in complete sentences to answer. Okay, so if I look at 100x squared as y1 versus 0.1x cubed, based on what we said above, x cubed should be larger as x goes to infinity. So I'm going to say y2 will be larger as x goes to infinity because, and this is the explain part, the exponent of cubed is larger than squared. So now we can verify that with a table of values. Let's look when x is 10, 100, 1,000, and we'll even go to 10,000 and 100,000. And we're going to use our calculator. So in y1 I'll put 100x squared, and in y2 I'll put the other function. And to look for these really large values of x, there's a neat trick we can do in our calculator. If you hit the second button and then window, change the independent, where it says independent, highlight and hit enter on ask. Then we're going to go to second y equals, which is the table. And you can type in x values. So you can type in 10, 100, 1,000, 10,000, 100,000. And hang on, I'm going to do that on my handheld calculator, and then I'll import a picture so you can see it here in the video. Okay, so here's what my calculator looked like on my desk. And you see these E's. So the E's is scientific notation. So when you have 1E8, that means 1 times 10 to the 8th. So the decimal moves 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And we put all these zeros in. Well, let's see, that's 1,000, million. So that's 1 billion. And then E to 10 is 10 places to the right. 12 is 12 places to the right. So you can see, regardless of the coefficient, where we had 100 as a coefficient versus 0.1, when we go to infinity, this 100,000, the cubed, x cubed, is still bigger than x squared, regardless of the coefficient. It all comes down to the power. The higher the exponent, the higher exponent will dominate. So because the exponent cubed is larger, that's the graph that will be larger as x goes to infinity. Okay, so we're going to do the same thing in number 4. We're going to pause the video for you. Oops, that's not what I wanted. To draw these graphs. I don't want you to see that yet. Good enough. Okay, so we've got x cubed and 2 to the x. So now we're comparing a power function to an exponential. And this first graph goes to an x value of 5, then we go to 11, and then all the way over here, this is in the 70s and 80s. So we'll pause it for you to graph them. So in comparing, if I want to think about as x goes to infinity, which graph will dominate and have higher y values? Because in the exponential function, the x is going to take on the infinity, this exponential will eventually have the higher exponent once we get past the value of 3. So Eventually, the exponential function overtakes and is bigger than x cubed. In fact, every exponential growth function will eventually dominate every power function because as x goes to infinity, the exponent is going to infinity, and therefore the power is higher than whatever the constant power is in the power function. So we'll pause the video here for you to write that down in your notes. Okay, and your homework is packet pages 11 to 12. Just these problem numbers. Make sure to check your calendar. We still have a quiz on Thursday. So here are your homework problems. 1, 3, 5. So don't do 2. There's extra. Don't do 2. Don't do 4. So just do 1, 3, 5, 9, and 19.